Hi, Chris Dicker from Ifm here. Today we're going to program in a bearing. Now I'm assuming that you've seen my previous two videos, so we've actually started a project. But basically all we want to do is create just one object. But we're going to need a dynamic input, so make sure that you've got at least one accelerometer connected. So here we've got a VSA 001 connected, our MEM sensor. So we need that for starters. The next thing that you need to do for a bearing is you must have a trigger. So you need to have a speed input of some sort. So basically just right click on triggers and you'll see here you can either have a constant speed trigger or you can have a variable one. My machine here is constant speed, so I'm just going to put in what it is. It runs at 1485 roundabout. So I'm going to put in that. It actually has to be pretty accurate, so if you're not on, you'll see what I mean later on. If you're not right on the speed. So you can also do, I'll just show you, we can do another one. I'll just do a variable one. We have to do an analog input. So on analog input before, actually I'll go back to here, you actually got to turn this on. So analog input, and you'll see here, if I double click on it, you'll see all the parameters for it. So if I hit the drop down, you'll see you can have an analog current. So if you've got a VF drive, you can get the analog directly out of that. But if you've just got a prox, and a prox is the most accurate way of measuring speed because we don't get any slip, digital pulse is what you want. So then you need to know how many revolutions and how many pulses it's going to be per rev. So normally it's going to be 1 if it's on a keyway. If you do it on a coupling, you might have 4 or 8. So you just put the correct number of pulses per revolution there and you're pretty much done. Then you need to have that trigger. So here's the analog in and it's set for pulse. Here they don't differentiate between analog until you get into this part here. But this part here you do need to put in around about the right speed. So if we're looking at 1500, 1485, 1500 will suffice perfectly there. Okay, so once you've got your speeds right, you can create your bearing. So if you click on objects, you can either click on a right mouse click on it and go through the bearing wizard that way, or if you want, just click on the icon, you can do that. So if you had all 4 sensors, that you'd see them all there and you can do them all in one hit. We've only got one just to simplify things, so click on that. So there's our first object. So sensor 1, it's a bearing diagnosis and it's diagnosis number 1. In the software, I like to mark what I've programmed in there because there's no other place that it comes up. So if you know what the bearing is, so if we put in an SKF6205, which is what my bearing is, and go next, it'll say how do I want to put that in now. So we're going to just browse the bearing database, so that's fine. Click on next and then type in 6205 and press search. Once you do that, you'll see that all the different brands of bearings in there, and you'll find that it's very, very important to know, if possible, which bearing manufacturer made that bearing. This one here is not actually too bad because there's only a few different bearings in there, but if I put in the wrong one, I'll show you what will happen. So my correct bearing is this one here, down here, 6205 SKF. So if I click it, you'll see this little green dot coming there. If I click one of the other ones, say the SKF economy bearing 6205E, it's got 8 balls rather than 9 balls, and you'll get a red indicator now. That means that it's not going to be terribly successful. The bands will be too wide and you won't get proper monitoring. So that's why it's very important to train your people, your fitters in particular, to let you know what manufacturer the bearing is. Okay, so we click on next. We've got the units, and you'll see the frequency factors. So these frequency factors are multiplied by the speed. That's why you must have a speed input in there, otherwise it won't monitor correctly. Okay, so there we're done. You can actually make a window to make it wider or narrower even, but normally most people will leave it on 2%, and that's fine, as long as you've got the right bearing. Okay, we'll go next. So we're going to use the speed trigger. It's automatically defaulted there. You can use a reference value as well, but most cases it's not necessary. And this is the speed that we're going to use. We could also use the analog one if we wanted to, but the constant one is the machine that I've got here, so 1485. Okay, if you've got bearings that are on a pulley or on a gearbox, then you'll naturally need to change the object speed. But in our case, it's just 1:1, so that is fine. So we'll go next. This is the damage level for in acceleration. So the damage level set at 450 and the warning set at 250. Normally I change that to 350 because I don't see there's a point in doing it so low down. But anyway, we'll talk about that at some other time. Anyway, we finished that, and now you've created the bearing here. So all you need to do now is to connect this unit. And you'll see the green indicator there. We can save it, and we need to also write it to the unit. It says that I do not have an alarm configured, and therefore no output either, and it's quite correct. I didn't do that, so let's do that now. We'll just go to alarms. Let's just get rid of it anyway. So if I go to alarms, new alarm, and if I put a warning alarm in, you'll see that that's the only unit in there for under warning. And if I go to alarms again and put a new alarm for damage, it'll automatically create one for that too. So again, save it, write it, and you're done. Now we can actually monitor our spectra. I'll close this down, make this big. So you've got our spectra here. What we actually want to monitor though is our Henning window fast Fourier transform, demodulated data if you will. You also want to click on sub-objects so that you can see what you're doing. Now, because it's a fixed speed object, you'll see this is the outer race, this is the rolling elements, right there, and this is the inner race. So when you program in that correct bearing, those traces are there automatically for you. If it was a variable, you wouldn't see any of these until the speed started to come up, and then they'll start ramping up to the right speed and stop on that speed. But anyway, I've got a good bearing in my unit at the moment. When good bearings are spanned and they're in very good condition, they're a perfect rolling element, and they will have very little signature and probably none that are close to what we're looking for at the moment. So I'll show you that. There's a little bit there, but that may not necessarily be the frequency of the bearing. So you can see very low amplitude and nothing actually on our bearing. So we can actually have a look at our damage level screen. There's the bearing there. There's very little noise in there. You can even show it as a table form if you like. So this will change state if it goes into a yellow alarm warning or a damage level alarm. You can see my speed there. Let's go back and we'll go back to our spectra. Okay, I'm turning it off. And I'm going to change that now to a damaged outer race. So I've got a bearing here. That'll just change over. Quick change. So now you can see on the outer race, you can see all the lovely harmonics. You can actually see a bit of damage on the inner race, the rolling elements as well. And you can probably see some slide bands as well. So no shooting that you've got a problem here. So you can see straight away they've got almost a G of energy, over a G now. If I have a look at the other unit, this will change state, and you can see exactly what it is. If it was variable, it would be monitoring my variable speed as well. So that's your outer race. So I'll just go back to our spectra again. And we'll just say disappear. I'm now going to show you what damage on the inner race of the bearing looks like. So this is the same bearing, but now we've got damage on the inner race. So if I start the machine up again, you'll see now that the damage is stopped from the outer race now to the inner race. With a different set of harmonics, it's a totally different picture altogether. Again, we can show you the harmonics. Fundamental frequencies, and you can see where the harmonics are. So again, very easy to see that you've got a problem. Again, if you have a look at the damage level, can see that we've got a big high spike there. And 1.3 Gs there. You can have a look at it in the table form as well. Yeah, so there's no problem there in just ascertaining that there's a problem with that bearing. Okay, that's all there is for me to do at this stage. So I hope you enjoyed the little training session, and good luck.
IFM, close to you.